Hello, welcome to our CEEGS webinar. My name is Marko Komac, and I'm going to be your host today. And today it's going to be a really interesting webinar, as you will see. The title is Regulatory Framework Requirements and Technology Roadmap that our esteemed guests will address. First, we're going to briefly introduce the CEEGS project that is hosting today's webinar. And of course, the presenter will be our esteemed colleague and coordinator of the project, Ricardo Chacartegui. And he's a professor at the Energy Engineering Department of University of Seville. He obtained his PhD in 2005, and since 2006, he has more than 150 documents registered in Scopus, so he's very productive, and over 80 publications in international congresses since then. His main research fields are related to, of course, energy storage, novel energy systems like the one that we are addressing in CEEGS, and LCE technologies. He has participated in over 60 international and national projects, so he's very productive, and luckily we have him as a coordinator. And also, he's participated in he patented 9 patents with the industry partners. And he, like I already mentioned, is the big boss of our project, but he doesn't act like that one. So he's really a nice coordinator and everybody likes to work with him. So enough for that. Ricardo, please, the floor is yours. Give us the intro on today's workshop. Thank you.
Okay, thank you very much for the very nice words. So I really enjoy working with the rest of the consortium. Probably that's the reason that we were talking before about the success that we are having with this project. Everyone works very hard, and the big compromise that we are having for from each partner. So I will go with a very short introduction of the concept of the CEEGS project. I will share my screen. When we start this project, so we looked for a large scale energy storage system combining the advantages of the transcritical CO2 cycle with geological storage. Having the meeting today and having the blackout of yesterday in Spain, Portugal, and in some regions of the south of France, so it looks clear the need of large-scale energy storage capacity systems. The advance of renewables requires specifically that this typology of systems. Please be aware that we are not competing with other technologies like batteries used for another scales and another period of times. We are talking of large scale capacity for terawatts at a worldwide level, and also considering seasonal energy storage capacity. There are only 2 existing technologies with that capacity: hydroelectric pump and compressed air energy storage. And with our concept, what we try is to introduce a new one technology based on well-known components or already under a reasonable technology readiness level of development that integrated at the level of surface components and at the level of underground technologies, we are able to provide benefits compared to other existing technologies, finding an opportunity for further development. So this is a 3 years project. In this one, what we are doing is combining renewable energy system. This is the main part of this is the main approach, but also having as benefit the capacity of CO2 geological storage, and also depending on the characteristic of and depending of of the location, of the terrain, but also depending on the depth, we will have also additional or potential geothermal heat extraction. Or primary is a renewable energy storage system, but the other two characteristics makes even more interesting the approach. What we are doing in this project is trying to give answer of how to integrate the surface system, a CO2 heat pump with coal and heat storage, with compressors, with turbines, heat exchangers, with the underground system where we have the wells, we have heat transfer with geothermal, we have plumes or salt cavities or cavities. So we have a number of components and elements that are common to different areas. So we are dealing in this project with different areas, with different knowledge, and with different approaches. And our main challenge is to solve the issues linked to the interface, where there are no previous experiences related to that. Please consider that we are having a different behavior than the one that we have, for instance, for carbon capture and storage for permanent sequestration, CO2, because we are filling and supplying CO2. So we have a process in which we have regarding time periods that are completely different and different boundary conditions of the usual ones when we consider for CO2 injection and permanent sequestration in the terrain. So how we are storing the energy? So on one hand, we are storing energy as mechanical energy, the work that we are doing in the compression, plus the thermal energy storage. So besides to this energy storage, due to the but Carnot battery that we are constructing or we are conceiving for the process, also we have additional geothermal heat gain, depending, as I said before, of the location. And also, depending on the characteristic of the geological formation, we can have an important or a relevant residual trapping, so contributing also as a decarbonization tool. Using CO2 as a working fluid has several advantages. So it has a low supercritical temperature and moderate pressure. It means that we can close the cycle with relatively low temperatures, so that can fit properly with different applications, let's say district heating and coolings, let's say industries, so many different applications. And also the CO2, we can take advantage of CO2 thermosiphon effects, so to reduce the work consuming, the energy consuming in the circulation of the system, and also, as I said before, the potential enhanced geothermal heat extraction. What we are doing? So we are, in these 3 years, we are advancing in the concept of a novel concept that integrates thermoelectric energy storage based on the reversible transcritical CO2 cycles and CO2 storage in geological formations. Why we are doing this? Why we started this pathway? So because we identified as an scalable system with high performance and high capacity energy storage. It can be used for electricity in excess available in the grid, the situation, as I said before, of yesterday, and also because we are having thermal energy stored in high temperature, 150 to 100 Celsius degrees, and energy stored at low temperature, around 0 Celsius degrees, They can be integrated also for industrial application, for district heating, and so on. This versatility introduce minimize cost and surface impact and allows different optimal configurations depending on the location and the potential uses. How we are doing this? So we will develop a proof of concept based on the integration of models, components, and a lab demonstration for the surface components. So the object of this proof of concept is fully focused on what happens in the interface. When? So I said talk what, why, how, when. So this we conceive this project as the first stage in which we are addressing the challenge of the interface. We are analyzing different situations, different locations, different configurations, and with that we identify if our preliminary results, very promising results, were as are maintained in different circumstances. I can say that today, in the third year of the project, we all the expected results, all the expectations are maintained. So we have seen that the results are pretty good. There are plenty of potential applications, and that it can be applied in many different locations with very good and very interesting results, and that the main challenges identify they have potential solutions. With that, what we expect at the future, in the in the next future, very close from now, we will start to go to rise the technology readiness level of the technology in another project, still to be granted, not just received, even still to be prepared to go to a higher technology readiness level 6, to be completed the commercial pathway in a third project going to commercial, and of course it should be impulsed by big companies to take advantage of the technology and exploit them. Who is implementing this project? So we are partners from 5 countries, 20 associated affiliated entities through EFG, and we have multiple skills regarding energy system, energy storage, geology, geothermal system, and situ geological storage, and so on. So on. It's a really, really good consortium with extraordinary skills and very good predisposition. So it's a really, really good one. So, that's a global imagine. No, sorry. What are the main objectives? To provide scientific proof of the technological feasibility of the transcritical cycle with geological storage. So, and we have 3 main challenges. The first one, integration of surface and subsurface components to a system. So, a study of the different components that integrate the system. The second challenge is the conceptual design of novel components adapted to the requirements in this novel operation methodology that is different to previous technological approaches. And the third branch, as important as the previous one, are the techno-economic feasibility and impacts. Taking into account not only those parts related to economics, not only to environmental impact, but also assessing the key dimensions in the social acceptability that are relevant, really relevant for the success of a technology. What we expect if everything is successful and reaches the commercial stage, making extrapolation of efficiencies of the systems and based on other existing technologies. We expect very high round-trip efficiencies, around 60%, even higher, uh, quite reduced levelized cost of electricity, thinking also of the technology as a grid balancer, but also integrated in renewable plants as a backup system. Quite competitive energy storage costs. So these are forecasted numbers, but they are maintained after the analysis and calculations that we have done during the project. Still running, but we are quite advanced. We are in the third year. And that's all from my side. Just one small final comment. You can see all the information about the project in the link that is here, ceegsproject.eu. And there you have, if you allow me, there you have, allow me just 1 second, plenty of information about our technical reports, our videos, our news, and media resources. So if you are interested about our project, you have different videos, but also you have, for instance, the fact sheet explaining the main concepts, the main parts of the project, but also frequently asked questions. So you see that we have plenty of information within our project. And that's all from my side. Thank you very much.
Thank you, Ricardo. That was very interesting. And I do encourage everybody to go and check our website because it's lots of interesting stuff in there. And you'll be surprised how advanced the CEEGS has come in these 2.5 years. And like Ricardo has said, it's just the beginning. So we are already thinking further into the future. So thanks again, Ricardo. And if you allow me, we will now move to the second presentation. That is going to be done by Pavlos Tyrologou and Christina Karatrantou. Sorry for misinterpretation. And let me just introduce them. And I'll start with a lady, if you allow me, Pavlos. So Christina is a GIS engineer with BSc, with a bachelor's in geology and with master's in geoinformatics and biotechnology. So she has 2 masters. And she specializes in GIS, remote sensing, and spatial databases, transforming really complex environmental data into actionable insights for environmental consulting, sustainable energy, and urban planning. Her experience spans high-impact European and public-private partnership projects focused on cross-border and environmental resource management, including EIA, support and regulatory reporting for CO2 storage and infrastructure development. Now, Pavlos is a passion geologist, and he has led a lot of very different stuff, and his portfolio is enormous. So he's a career geologist. He does editing on the side. He's a project manager, expert witness, and consultant, mainly in Greece, but also in UK and for European organizations in Brussels. But he is so very active that his work has led him also to work in Australia, Madagascar, San Martin, and Caribbean islands. Lucky you. Hopefully you did get some dive in that beautiful blue sea. So he was born and raised in Athens, but his seek for knowledge led him to UK, where he spent almost a decade working as either studying and working as a consultant. He took his first degree in applied geology in Glasgow, then followed with his master's in Cardiff, and then finished his studies with PhD in London at the geotechnical engineering at Imperial College of London. And after that, he also worked as a consultant in UK. He is involved in CEEGS project through EFG, founder of the project, through his long association with EFG, the Brussels-based European, um, uh, let's say, Association of Professional Geologists from 28 nations, so quite a wide network of experts. And he sat on EFG's many expert panel, from natural hazards and climate change to CO2 storage. And he's been very active in the organization for over a decade. He's also an EFG's external relation officer, and since 2020, he's the chief editor of the European Geologist Journal, as has a lot of work to do because it is published twice a year. So that's been a really long introduction, and I'm totally tired now. So I'm going to leave the floor to these excellent two presenters, and I don't know who's going to go first. Is it Pavlos or
No,
Christina?
it's going to be me. If Christina, you can
Okay,
share your screen. And in fact, I'm just gonna present only the first 4 slides, and then the floor will be taken by Christina. So
excellent.
yeah,
Please.
yeah,
Thank you.
Marco. So many thanks. Just a brief introduction of the team. I'm also working for CERTH, and actually my presence here is present of EFG and CERTH. But the team here at CERTH is also comprised by Christina, and it's being led by Dr. Kukuzas. And I'm talking about the CERTH part, which is focus on the geological domain, because other people also working at CERTH, which are more related to chemical engineering and mechanical engineering, and responsible for the surface process of the project, doing great work, actually. So if we can go to the next slide, please. One of the major things about what we're going to talk is about the European Union policy, how this project actually has been initiated, meeting the Green Deal, meeting the EU taxonomy objectives, and creating space for business development, actually, because one of the major things related to this project is how it's going to be progress, as already Ricardo mentioned, and eventually commercialized. And in order to achieve this, certain things need to be understood, especially what is the permit procedure, what is the current legal requirements, obstacles, and opportunities. So this is one of the major things that actually Christina is going to introduce you, and then, of course, we may also discuss. Next slide, please. And yeah, this is what is gonna pretty much set the legal foundation for CEEGS. The taxonomy recognition, the subsurface ownership and storage units, who has what. Second part, what is the licensing and monitoring rules for this kind of projects. Environmental and impact assessment provision, which is also part of the permit. How is going to integrate it on the market for future purposes, and then the taxonomy. And one of the most interesting things about taxonomy, especially here in the European Union, is like pretty much is gonna dominate future market, because basically only projects that presented and are green in nature are going to be financed, okay, from basically the markets or from national funding or European Union funding. And in fact, even with Horizon projects these days, during the proposal stage, you have to demonstrate that your proposal, our proposal, meets the taxonomy regulation and objectives, otherwise it cannot get funded. So it's the same thing. So it's very important. It's very important that projects and concepts like ours falls within the EU taxonomy. And I will leave it to you now, Christina. Thank you.
Okay. Hello from me. I'm Christina. First we will see what is CEEGS project. CEEGS will develop a cross-sectoral technology for the energy transition. It is crucial to combine renewable energy storage system based on transcritical carbon dioxide cycle, CO2 storage in geological formations, and geothermal heat extraction. Which is the main objective, is to provide scientific proof of the techno-economical feasibility of the technology, and which raising the current low TRL2 to TRL4 by addressing gaps in the interface between surface, transcritical cycle, and the subsurface of CO2 storage. The main objective, the main aim is to offer flexibility, decarbonization, and storage all in one solution. Here is our legal context, EU legal context. As we can see, the European Union provides a very strong legal foundation for projects like CEEGS. At the top level, we have climate and sustainability legislation. Here we can see which legal frameworks commits to the EU net zero emissions by 2050, which at overall sets the target for climate neutrality. We move on with the energy system and market integration, which is we were set the technical criteria for the electricity market and the energy market. And at the end, we have the CO2 storage and certification framework, which provides the pathway to certify the carbon dioxide removals and storage. Together, all these can set the legal framework for national system on how they must apply them. Here is our national focus. All the surveys have conducted by the EFG. We will see that 15 countries have submitted their structural legal review under the task 6.4. The survey has very specific questions in order to see how they are the national legal systems. And this is a very strong basis for a comparative analysis among European countries. We begin by separate the European countries according to their location. First, we have Central and Southern European countries. In the table, we see very few things in order to make a comparison, such as which is the country, the storage law, the geothermal law that they apply in projects like CEEGS, the permit authority that each country has for such project, the EAI required, if yes or no, and if they are aligned to taxonomy, to EU taxonomy. According to this table, we see that Greece and Germany has a very dedicated authority and according to CO2 permitting pathways. Serbia and Poland has a more general law, which is about mining. And finally, Slovenia recognized recently the geothermal in its energy law, but it lacks on CO2 legislation. Now we are moving with northern countries, which is Sweden, Estonia, Ukraine, Bulgaria, and Czech Republic. According to their questionnaire, we have come to conclusion that the Eastern countries saw a growing interest in but fragmented legislation. Czech Republic and Bulgaria are the most recent countries that has now moved toward taxonomy integration. And Estonia and Sweden, as we see in the table too, has very few dedicated storage law, but they are more focused in geothermal provisions. Now we have the rest countries of the questioners: Spain, Turkey, Croatia, Belgium, and Luxembourg. Turkey and Croatia are the more advanced in subsurface regulation than the other European countries. Spain has Spain regions vary in regulatory clarity. That means that the law is different from region to region by region. And finally, we see that Belgium and Luxembourg are the countries that are still drafting on relying regional law on regional laws, and they are not so they are not have so many general geothermal laws and CO2 storage laws. According to the EFG surveys, we have chosen 3 countries in order to make an in-depth comparison with taking into account their most important feature that we have seen. We start with Greece, which promotes a centralized model. According to this model, Greece has an integrated, updated legal framework, has also dedicated licensing authority, which is HEREMA, and it's responsible for CO2 storage and exploration. And Greece, we could say that is an early mover in linking geothermal and CO2 storage too. Moving on with Germany, we see that it has a federal region-driven model. It has implemented the pilot activity in Cajun region, which promotes advanced CCS. It shows also strong MVR protocols, but has some regional variations in law implementation. And finally, we have Russia, which promotes a transitional model with sectoral overlap. It promotes a very comprehensive mining act, which combines both CO2 and geothermal activities. Has dual use of regulations for its cases, and it's a great example of how hydrocarbon law can be leveraged. These 3 countries that I mentioned before, they are compared for their key laws and structures. Here we see the main laws of Greece, and his responsible authority for CO2 licensing, exploration, and storage activity, which is HEREMA and Ministry of Environment and Ministry of Energy. We're moving on with Germany, which has authorities responsible for CO2 storage, State Mining Office, and Federal Environment Agency. And Croatia, which authorities are Ministry of Economy and Sustainable Development. We see that all of these countries involve their Ministry of Environment and environmental organizations for projects like CEEGS. Some legal highlights of each countries. We could say that in Greece we have a very strong dedicated CO2 storage law and the authority organization. We have implemented geothermal regulation in renewable energy sector, and we have strictly aligned with EU climate law and taxonomy. Moving on with Germany, we have to say that this is a country which has pilot activities already, like in Cajun region, has already established MRV and risk tools, and has to show very clear rules on liability and site closures. Finally, Croatia has a very unified permitting mining law. The CO2 is classified as injectable resource in their law system. And in any case, they required environmental impact assessment for activities for deep geothermal and CO2. Despite their impressive their impressive legislation system, we have each country has a very some challenges to face. In Greece, the most important challenge is that some laws are overlapped. For example, environmental and energy permitting procedures, and as far as public acceptance and local consultation are concerned, we are still evolving. Croatia, on the other hand, so the mining law focused mainly on energy storage project, and it has a lack of alignment with EU taxonomy. So until now, they are not very involved in financing green projects. Germany, we see that CO2 storage are not allowed in most states of Germany, and the permitting procedures and legal framework are different from state to state, and that's not doesn't allow Germany to have a general law related to CO2 storage. But why these countries and and their national framework according to CO2 storage and geothermal energy is important for CEEGS? The main characteristic for Greek legislation system is that the model is centralized, allowing cross-sector permitting. The German law shows very strong legal system with which can both enable and complicate the deployment in federated states. And finally, Croatia can implement a very transitional model with existing pathways for CCS. Here is a table that makes a comparison and a comparison according to EU countries, European countries. We see that around 2/3 have basic supporting in CO2 storage and geothermal regulation operations. Only 40% have a strong MRV system in place for monitoring. And we see that is just 1/3 are well aligned with EU taxonomy alignment. These divergences could significantly affect the deployment of CEEGS and similar technologies if not addressed. So the conclusion of that of this table is that more work should be done upon EU taxonomy in the national level. Here some legal gaps that I have mentioned through the survey of EFG. We see that the sectoral legislation is fragmented, and there is a lack of legal definition for energy storage. In some national legislation framework, we see that the CO2 handling is overlapped with hydrocarbon law. In that case, there are some permitting delays due to environmental impact assessment and EPA coordination. So the process of CO2 storage may be delayed. And we see that no national framework mentioned the link of CO2 storage with energy market, as we see that a project like CEEGS mentioned that CO2 storage is a theme, is an energy topic. Here we see some the most important highlights of European countries. In Greece, we see that we have a clear CO2 storage permitting authority, and that allows us to move on with a project like CEEGS. And being focused on that. In Germany, projects like in Germany, pilot projects have legal clarity and have dedicated MRV tolls. Slovenia is the most recent European country that have updated their national law for geothermal and energy issues and activities. And finally, Croatia has national acts that covers geothermal exploration with very clear procedures. According to the survey, here is a short roadmap until 2030. At present, we have to establish national MRV schemes. That is a base map or baseline for the next 2 years in order to define CO2 storage ownership, and that allow us to have long-term liability in energy projects like CEEGS. And until 2028, we expect to harmonize permit paths and integrate with climate financing rules by aligning national legislation system to EU taxonomy. Some conclusions that have for task 6.4 is that while the European legislative base is strong, national framework will ultimately determine the success of project like CEEGS. This task, for example, task 6.4 legal survey provides both a map and of current barriers and a strategy for enabling large-scale deployment. And going forward, stronger national harmonization will be the key to realizing CEEGS contribution to European climate goal. Thank you for your attention.
Thank you very much to Christina and to Pavlos. This has been a really in-depth overview of the activities that you've done within European countries. It's excellent information for everybody. So I would stimulate everybody to hold the questions until the end, because we are running a bit late. Nevertheless, we won't stop before we completely address all 3 presentations and questions at the end of the workshop. So our 3rd presenter, or 4th presenter with the 3rd presentation, is going to be Eva Nanaki, and she holds a PhD in mechanical engineering, and she specialized in the field of sustainable transport system, alternative energy, and new technologies. She works at Hellenic Energy as a new technologies and innovation analyst, and is visiting lecturer of Aarhus University in Denmark. And she's responsible for the management and coordination of research projects supported by national and European funds focused on alternative energy sources, biofuels, hydrogen, and energy efficiency. Responsible for the market analysis, business models, and feasibility studies, following competitive business trends and conducting cost-benefit analysis for the group's new activities. She's very much active in that field too. She has published 2 books, and in the field of electromobility and energy analysis of renewable energy systems. And she has more than 150 scientific papers in journals and conferences. Also very impressive. And Eva, please, the floor is yours, and lead us through your presentation. Thank you.
Thanks for the invitation. As we have already discussed, we're not going to have a presentation because our task is still ongoing and we have not yet completed the task, let's say. I represent Hellenic Energy. Actually, it's one of the biggest energy companies within Southeast Europe. Our activities are spanning within the refinery sector. Our group represents 3 refineries, 2 in Athens and 1 in Thessaloniki, and we span our activities in different areas. Our involvement in this project was very interesting, and indeed it has opened new, let's say, doors in what we can do in order to decarbonize our refineries, our core activities. Our involvement in this project actually involves the development and the creation of a roadmap for European countries exploiting the CEEGS technology. In this direction, we're going to, let's say, collect all the findings from different tasks within Working Group 6, and we're going to gather and summarize it in creating a roadmap that will introduce to industrial players a new paradigm for sustainable, let's say, CO2 storage. The tasks that are being involved in this deliverable includes summing up the technology risk analysis, which has been performed in task 6.1, and these tasks actually assessed the risks of the technology for all categories, including geological, technical, environmental, social, and economic. This has been both in the local, regional implementation case, and also for a general extension of the concept on the European scale. Then we're going to collect all data that have been gathered in regards to the decarbonization assessment and potential of this technology. As you know, there is a lot of refineries all over Europe, and in Spain especially, there were identified 132 industrial emitters, presenting a huge opportunity to decarbonize this sector. So, after the completion of task 6.2, we're going to gather all this info and info regarding the potential of decarbonizing sectors such as the cement sector, the refinery sector, and the possibility of having negative emissions, which is something very important, especially taking into consideration the greenhouse gas balances. After completing this, we're going to gather info from task 6.3, which involves actually findings from the techno-economical analysis and life cycle analysis. After this conduction, we can have estimations in regards to costs of drilling cost, the production cost for a certain period, cost for the pumps and surface installations, cost for the CO2 cycle, and also other operational costs, which are very important for all big industries. Then we're going to perform and execute and analyze some business models in regards to the viability of this technology and relative market scale-up. Business models which are being currently developed include some license that can be sold, include also the assessment of the technologies and their relative risk and how these can be implemented and in industries and reaching higher TRL levels. And also the business models include also some ideas about carbon capture and storage services that can be promoted. And after taking into consideration and completing all these tasks, we are going to present our deliverable for which we are responsible. We hopefully think that in beginning of July, this will be ready. This was from my side.
Thank you, Eva. This was also very interesting. So I think we have another opportunity and the reason to meet again to see the final results of your study. So this would be very informative for everybody, and also it might open some or trigger some new ideas, the same as Christina's and Pavlos' presentation did, and hopefully triggered also some questions for today. So thanks again to all four presenters. Now I open the floor for questions. We usually put them either in chat, but you can also just raise your hand and then I'll just give you the floor so you can actually ask it in a verbal way. So please, I've now opened the participants list. So if anybody wants to ask something, now is the time. Ricardo, please.
So thank you. Yes, thank you very much, Eva and Christina and Pavlos for the presentations. One thing that we are talking internally is about what is the threshold regarding the cost for being viable, this technology, taking into account the investment, and related to that, what is the size? So I know that now it's very early to say something about it, but I was wondering, I don't know, maybe for Eva or maybe for Christina, what about the size regarding the legislation? What about, we're talking of this side regarding cost and this other side regarding cost, the effect of scale. But what about the legislation about that? If you can say something about that, just curiosity. I don't know, Christina or Pavlos or Eva, if you. If not, we can leave it open for the future.
I think Eva can give you the answer.
Yes. I think that Ricardo, it's too early. We'll have to see some numbers in regards to the capex OPEX after the completion of the techno-economical analysis. And perhaps I think that we should mention, let's say, a funding roadmap for this. It's not easy because I think that the size is not going to be a smaller, it's going to be a big size. We will need significant funding in order to implement and to proceed to significant investment. Perhaps a partnership or a public funding and private funding, this would be a viable solution for the implementation and scaling up of proposed suggested technology. It's quite interesting, and the work that has been done in this work package, it's huge. I mean that all the regulatory issues have been taken into consideration, the environmental impact, the techno-economic analysis that's going on now, as well as the regulatory framework. These are huge, let's say, assets that can help us and bring them to top management, bring this to public authorities and say, you see, we have quantified relative costs, regulatory issues, environmental impact, and this is something that we should invest on. This is my point of view.
Thanks, Eva. Christina, would you like to add something?
No, I think that it's early to answer that question.
Yeah,
Okay, thank you.
We need more data.
Okay, sure. The idea came to me because we are all considering two different uses of the technology as integrated within the electrical grid, not linked to any specific location, but just to stabilize the grid, and so it can be so big as you can. So it will have some relative cost, but also some regulatory issues. But also we are considering smaller ones, let's say 5 megawatts, integrated or linked to photovoltaics, wind, or other, just in the same facilities and in this, let's say in a common project with the renewable project. So that was the reason I was taking to discussion this. It's not the same to consider a big project specifically for CEEGS, 100, 200, 300 megawatts, and we have a big project related to that, with all the issues regarding costs and regarding permits and regarding works, and a smaller one considering to be the support, the backup of a specific facility, with, of course, will be more expensive per kilowatt, but it will be related to the project and the regulatory issues on the permits linked to the renewable plant.
I can say something on that.
Yes.
Now, sometimes we feel like the legislation comes first, and then the project develop along what the framework of the legislation has provided. Actually, this is not the case. Usually you have the projects that we learn from, and then we adapt or create the relevant legislation. Now, because we over-legislate as a society, we try to find also where there might be the case that when you develop a project might actually fit on the current regulatory framework. Now, for instance, with CEEGS, though, that it remains to be challenged. For instance, if we move to something smaller, let's say a small commercial scale, and we will go through the permit process, it will be challenged. And, it will be provided feedback. And then we may also find out that there might be needed legislation amendments at a national level. But this is usually the case. And then, of course, the first or two or three projects developed by companies is the ones that they face the most difficult task, okay? And then you have maturity. You have project maturity and legislation maturity. And everybody else, then they have an easier life, if you like. But it's usually the first two or three that they face the most difficulties when it comes to legislation and permit process.
Who enjoy the process more, yeah.
Yeah. But but this is how actually is be done, and because you have also the regulatory authorities that they learn. So this for them, for instance, if you submit a permit application for this kind of project, they will know nothing.
Yeah.
Okay, and they will understand, and they will start learning also. So it's a long-term process for all parties involved.
Well, it's usually quite common with new technologies like CEEGS, but the good thing is we have this flexibility, like Ricardo has pointed out. We either go for the stability of the grid, or we go to the specific small scale, let's say, facilities that help support the local communities or the communities or industry, whatever. And I would see this also an opportunity, because if you're the first to start cutting the let's say the ice cover of the technology, you have some advantages also because you can co-create and co-help to co-create either the development of the technology, but also the development of legislation. So it's I would say it's a mutual and win-win situation. Of course, it has some obstacles, but like everything in life. So I think it has a good opportunity and a good future, this technology.
Absolutely. I fully agree.
Okay, are there any other questions or comments from the audience? We've received two congratulations.
Yeah, there's one from Georgetta, actually.
Yeah, and she has to review the webinar, but she didn't quite understood how and where the energy will be stored. Is it at surface or underground? So we should clarify that. It's rather simple, but please, Ricardo.
Yeah, most of the energy is stored underground in a combination of mechanical energy plus some geothermal capacity. There is a fraction that is at the surface in the hot and cold tanks, but mostly it's underground. Mostly is the mechanical work performed uh, by the heat pump, compressing the CO2 through the mechanical. But there is a component in the surface tanks, in the cold side, cold tanks and hot tanks that contributes in the closing, so to close the system. The idea of a reversible cathode battery without the geological part has been developed by different even companies. The company MAM, they have a concept related to that. The difference with this concept is that we close the cycle instead of closing it in the surface. We introduce the loop. We close the loop with the underground. So with that, we increase the energy storage capacity because of the capacity of the underground reservoir is increased by orders of magnitude, and having also the additional benefits of the geothermal with the potential CO2 sequestration depending on the characteristics of the underground, and also the potential thermosiphon capacity. So we are having thermosiphon, geothermal capacity, and potential CO2 sequestration. So let's say it's a Carnot battery, but closing the loop with the terrain.
Thanks, Ricardo. I hope, Georgetta, I hope this was clear enough, and I see your thank you note, so I guess that was clear enough. Thank you.
And you can contact me if you want directly by mail, and I'm happy to share with you.
Thanks, Ricardo. Thanks also for this. Any other questions or comments? I see none. So if there aren't any, I would then slowly conclude today's webinar. We've been almost on time, 10 plus minutes, which is good because it was interesting. We didn't just board ourselves. So I would thank you again to all four presenters. And thanks to all participants. I hope you enjoyed the workshop, and it's not the last one. So please join us next time, and we will have additional very interesting topics and stuff for you to learn from. And with that, I conclude today's workshop for CEEGS project. Thanks everybody, and have an excellent remaining of the week. Thank you. Bye bye.
Thank you. Bye bye.
Good day.
Bye bye.
Thank you.
You.